Hello everyone, welcome to the second stream where I'll be trying to learn ECS in Unity. So this time hopefully it will be much better. I've moved from the laptop to PC because laptop wasn't quite good enough for streaming. I mean the performance was a bit low. Also I'm a bit more prepared and hopefully will stream much longer. So yeah, let's get going with that. So I have the previous project open on my PC. So as the beginning, I think I'll just quickly show you what was done previously. Also for the new people that are coming out here, just to catch up, what are we doing here, how it's done. Right. So previously we first of all tried to kind of design our ECS architecture, the components, the systems. So we are aiming to create a simple game where there's a character, there's a player and enemy, both of them are characters, and as the first step we tried to create a basic character system. So each character can have statistics, the moving component, the health component, the attack component, each of them responsible for certain functionality of the character. Like character statistics provide us base movement speed, base damage, max health points that are used by other systems to compute some data. Character movement describes how our character is currently moving, so the current movement speed, current movement direction. It can be either set from some AI of the enemy, which we'll be getting into later, or from the player input. Next, the health points. So each character can have health. If health goes to 0, the character should be dead. And character attack time is just for attacking. So right now we are not making any special attacks for player and for enemy. We're just making a common simple attack for both of the characters. And it has attack start time, which will help us determine whether the character can attack again. So it's kind of a attack cooldown thing. And we've made some code. So we've made a character health component with all of the properties, as well as the other components. Later on, the player input component, which stores the current input from the player. And some systems. So read player input system, which simply iterates through each of entities that have player input component and assign the current input from the keyboard, get axis horizontal, get axis vertical, and assign them to the player input component, which is later on used by apply player movement direction system, which just takes those variables and assigns them into character movement. And later on, the character movement component and character statistics is used to calculate the movement speed. So we're just simply right now assigning the movement speed from the statistics to the character movement component. This is done in that way because we can extend it later by creating some effects. So the character can have a speed up effect, so we can move faster. Then we will, for example, multiply that by 2. And the final system, which is move character rigid body system, which takes a rigid body, which will base our whole movement on, just to have collisions and other stuff. It takes it and applies the movement from character movement component. So yeah, That's how it's done right now. It's working just a bit. I can show you. Let me move the camera because it's in bad position, so you wouldn't see much. So let's move it that way. It's here. Let's hit play. It's working so much faster than 2 days ago on laptop. Really, PC is better for streaming, I guess. At least my PC. Okay, so it's moving when we are hitting WASD keys. Our character is moving, and we can inspect some of the properties that are changing. So if I just click some access buttons, as you can see the player input is changing. Later on it's transferred to character movement, and our rigid body is moving. So as the first step today, I think that we'll do just small refactor, because as we're making it in the hybrid ECS, we're not making it the pure ECS. I took a look how I was doing it in my previous just research, and then I discovered that I did something like, just let me show you that. Can I move the, oh, I can't move that. I want to open a script in a new window in VS Code. Open in terminal. Where's that? Maybe let's do it that way. Oh, maybe something like that. Here. Oh yeah, it will work. So previously, when I was doing the research, I did create a component, a mono behavior called hybrid entity, which is basically adding our game object to the entity manager in Unity. Because if you want to use your game object inside of the entity world, you need to explicitly add it. That's required for the hybrid ECS. Previously, I think I remember there was some kind of a component called game object entity that was doing that, but as Unity is trying to shift away from the hybrid approach and more into the pure ECS, as they are moving a lot of systems to the pure ECS, they're disabling it. And as we're trying to make a hybrid ECS, because there's not a lot right now in the pure ECS, we need to recreate that one. So I'll just copy that one to our project. So it's just storing the world and entity, because on unable it takes the world, we're just caching it because it can change. So it's unsafe to just do something like that. Yeah, no, we don't want to do that because this could change, I believe. So just to be safe, we're storing that variable where we are registering this entity, and we are using this class. It's not, oh, I need to copy that one to have a suggestion. So let's create hybrid entity.cs. Okay, you go away. Yeah. So got definition. Yeah, it's class with a static function that adds our game object to the entity manager we point to. So we did it, and later on, when the entity becomes disabled, we want to make it disappear from the entity world, and that's why we are unregistering it, which is called destroy entity. But when it comes enabled again, it just pops up in the entity world again. And the second thing that could make our programming easier and faster and less allow us to create less errors is a script I called hybrid component.cs, and it does nothing but it requires a hybrid entity component to be present on the game object, so we can be absolutely sure that if we're attaching some hybrid component, this entity, this game object will appear in the entity world. So we can get rid of this register as entity component. And there's also a third thing I created and I forgot on the previous stream. It's called hybrid singleton entity. Alright, so we all know singletons are bad, but for the purpose of creating something in ECS, you sometimes need just one piece of component. So I mean, in case of creating a singleton with functionality, it's bad because when you, for example, want to write some unit tests, it's just a lot of languages makes it hard for you to mock that singleton. Also, it's some shared state. It's just bad. But in case of ECS, I think it's the singleton is just unlucky word out here because it's more like a component that has only one instance in the whole entity world, which is just an assumption. So it means exactly what singleton is, but I think here just using singleton component, so one component for the whole ECS world, it's not so bad as doing it in the object-oriented world. So I'm good to use that. You can blame me. All right, so it's just something like the hybrid entity. It hasn't got any code sharing. Maybe we should, because this is just the same as it is. Entity. It's so small piece of code. We'll keep it as it is. All right. So right now, let's go to our components and use hybrid component instead of mono behavior. It's also nice because we get rid of that using Unity Engine. All right. And let's get back to Unity. Let me check the chat. There's no one in chat. If you have any questions, just feel free to ask me. I'm really open to anything because it's not just me learning, it's all of us who are here. Okay. So this is a player component. This was our register as entity, and let's just do like that. Player input, and we have a hybrid entity which popped up here. I want to move it to the top. Can we? Still, Unity hasn't implemented some kind of a drag and drop sorting. That's bad, but never mind. Who does that? Alright, so let's just do one more thing, check if it's working again, as we made a little refactor. Yep, it is. Alright, so we have movement. Oh, let me close that second project, I believe. Yep, okay. We have a movement. Let's take a look back here, figure out what we would like to do next. So as we can move, let's just create an enemy enemy that will follow the player. So as we will have an enemy following the player, we'll be able to apply some basic combat system, some damage, some health, dying. Yep. So just one more thing. I'm thinking whether we can change that to character alive component and there store health points, and when character is dead, just delete that component. Let's keep it simple for now. Let's just leave it as it is and go with next things. Enemy AI.cs. So class enemy AI hybrid component. Oh, let me move my keyboard, it's in a spot. And what do we want in AI? Right now, absolutely nothing, I believe. Because we will create a enemy follow player system.cs. Let's code that. Keep typing public, that's weird. Enemy follow player system, and we will do it as an component system, which is in the entities. So component system can use just yep. All right. Implement abstract class, and we will iterate for each. Every entity that has enemy AI and character movement system, enemy AI, character movement. And here we'll type our code. So it's very weird syntax, but why I'm doing it like that, why I'm writing this whole thing like that, is because it's very easy to extend. So if I just want to add some new entity, new component, I can just put a semicolon here and go to the next line. If I want to reorder, I just move those lines. So it's much better than having all of them in one line. It's just simpler, and because the for each syntax requires to write like that, we have to duplicate ourselves, which is kind of a bad, but it's acceptable. Okay, entities for each, character statistics, character movement. I'm keeping here just one line and here now. Okay, I think this will look much better. So that's good. Yeah. Right, so here we have just a function. I'm worried about the indentation. Just look how much we have. 4 tabs. But let's just go and keep it consistent. Maybe we'll change it later. Alright, so here we are receiving enemy AI and character movement components, and we would need to find nearest player. So how do we do it? Entities, maybe somewhere here. For each, I believe. So we will need to create a second for each. But how would know that one entity is a player and the second one is not? So we need a kind of a tag system for that. Maybe a team component, character team, which will just yeah, I think we need that. So let's create a component character team. Let's copy that. Hybrid component character team. For now, let's just put team ID, or maybe just ID. So this will be ID of our team, and if the ID is different, we know that those two characters are enemies. So it would be good to create a function called our characters enemies. So maybe we'll create one. So those functions will be used in the component system, I believe. So can we just create a base class with those functions? And how do we even call them? Let's, for now, let's name it common. And create a function r characters enemies. Yeah, and let's create a public static partial class common. Let's create a function r characters enemies, and will be character team 1 and 2. Alright, and we return the character team 1 ID is different from character team 2 ID. So that's how we know that the characters are enemies. Consistent is less accessible. Okay, so we need to do it like that, or maybe this needs to be public. Okay. So what was that? Okay, so enemy follow, it will be much like character follow enemy system. So instead of that, we'll create a character AI. And see, that's how ECS works. You start to think more kind of a generic, because you don't have a player object or enemy object. You have a character components. You're trying to build a character out of components that should be reusable, generic, and when you there's some kind of an issue, when you meet an issue, it's the solution always works very good for your code here. So you create a very generic code. So we started from enemy follow player system, and now we have character follow system, which is very generic because we can assign even to players sometimes to follow someone. That's good. So let's code it. We have entities for each character AI, character movement. We need to find a enemy, closest enemy. And we need transform of that enemy. So we did entities for each. We're searching. And transform from Unity Engine, and need character team. Here we also need character team. Character AI, that would be good name for that. Follow enemy system. It's good. Character team. That's all we want. Transform. Let's say enemy transform. Enemy character team. Oh. Owner transform. Owner character team. We don't know if it's enemy yet. So we need to check that. So if and instead of typing command dot, here is a static command. Very useful trick. Are characters enemies. So character team 1. So we'll type team 1 will be our character AI character team. Alright. Character team 2 will be other character. Character team, and if they are enemies, we would like to have a variable here. Transform. Let's get transform closest enemy transform, which will be null. And the distance, so float closest enemy distance, which will keep in closest. As 0 for start, we don't need anything out here. It won't be used, as we'll check for that. So if characters are enemies, and now we check if it's a closest one. So closest enemy transform is, so if it's no, we need to calculate the distance. So enemy distance will be vector free distance between A transform. Why do we need a transform here? The transform and B other transform. What's wrong? Oh, position. Position, enemy distance, and enemy closest enemy transform, or enemy distance is less than closest enemy distance. Then we assign closest enemy transform to other transform and enemy closest enemy distance to enemy distance. Alright. And as we have the closest enemy transform, we can just follow it. So it will be like direction. Oh, if it's null, we don't want to do anything, so we'll just return. Otherwise, we want to have a direction, which will be closest enemy transform, position minus transform position. And we'll assign it to character movement, direction X is direction X, Z direction Z. Later on we will need to introduce a path finding here, and I think that we need to do something like that. So here 0. Let's make it nicer. The outer format function is not working here, which is annoying. So I think it will work. Okay, let's just review it one more time for a second. We take transform, character AI, character team, character movement, and we search for the closest enemy and assign direction so our character will follow it. Alright. So we'll just copy that one, create a new material. Let's change the color of that to neutral, so our enemy is red. We delete the player input and we assign character AI. Character team, let's assign 1 for enemy and character team 0 for the player, and let's see what happens. So it follows us. That's great. It is pushing error. Alright, so what I don't like here is that we have some codes that is trying to find closest enemy here, which is not that good. Sorry. So I would like to have it somewhere else, some other function. Maybe we can do it as a extension method for entities. Let's just inspect what do we have from the component system, because right now we can't move it to the common section, as we don't have access there for entities. So let's try to see what does this component gives us, to see whether we can just create a common function that will take entities, or is it much more that we would like to use, and it would be better to put all of the common functions inside of a kind of a base class for the component system. But this is what I wouldn't like to do. So let's see. Let's start from system base. Okay, we have a time. So the common functions, I would like them to be as pure functional as it's possible. They shouldn't modify the state. So the only thing that they should do is just take some data and return some other data. Alright, time. No. You would accept it as data. Entity manager. Also I think we don't want to do that, because the common practice, as I was learning ECS, is that if you need to have a common functionality that modifies the state, it's good to have a system that performs those operations and just pass the requests to perform some operation to that system. Yeah. All right. Entity manager. I know, entity queries, enabled, world, some functions to hook into, entity query. What's that property? Nice. Should run system set singleton. Requires singleton for update. Oh, I see there's some singleton functionality inside of the Unity. That's cool. Okay, let's move forward. Oh, as I discover right now, I was not reading the chat. Why am I not using the job component system? I'm not listening because I'm watching this TV show. So, Bartek, I'm not using job component system because I'm writing this game in hybrid ECS. So I'm not allowed to use any jobs, as jobs are mainly for pure ECS, where you have everything in structures. And here we are using legacy game objects, just binding them as entities in entity manager. So yeah, and why I'm using the hybrid ECS, it's because the pure ECS is just it's pure, but it's poor. It hasn't got many things right now. It's just some basic 3D rendering. If you would like to do the 2D, it's almost impossible due to lack of the Z-axis sorting in the pure ECS renderer. So I'm going along with hybrid approach, as writing gameplay in hybrid approach doesn't differ much from pure ECS, because it's still a gameplay. And later on, when Unity introduces more pure features, like physics is already here, so what I would like to is a proper rendering handling, a better one, then most probably I will move this project to pure ECS and jobs. But right now, just hybrid ECS, just to get a bit of a feeling how to write gameplay in ECS. So let's get back to reviewing what component system base gives us. Some singleton functions, things connected to the updating, get component data from entity, the buffer from entity, it's more for jobs, archetype, chunk, component type dynamic, world, enabled, entity queries, and here the entities. So I would like to move that to some other function. So let's just create find closest character. Or maybe let's just create a function find character. Maybe find enemy. No, find entity. Not CS. You'll see in a moment what I'm doing. So find entity. And we'll use predicate for will it work? It will, but it won't be the performance will not be the best. So I wanted to create a generic function find entity, later on build find character on top of that, and later on create a find enemy and find closest enemy. But the issue is that when we have for each, we have to tell what components we would like to receive, and as here I would like to create a for each from the entities. It will be an issue. So here I need to know every component for the predicate function. Sorry for my cough. It's something bad happening. Okay, so let's just find closest enemy.cs. team. And entities, I believe, as the argument entity query builder. Okay, and let's just grab that code. Keep forgetting to type T at the end of the closest. Alright, and we would return. What do we want to return? That's a good question. I believe transform. Yep. I think it will work. So we just need to int engine namespace and entities from the lowercase and transform. Let's start typing character transform. Character team, enemy transform. Here, character transform. Under character team or character transform. What? Why I can't rename it? Okay, I can. That's weird. What is that for each ending? No, it's function ending. Character transform. Yep. And here for closest, find closest enemy entities. Character transform. Let's name it to character team. So first of all, when I'm using functions, I love to use named arguments, as it is it's not forcing you to have a good variable names or when you're directly typing a value inside of here. Later on we'll most probably get to the better example, but for right now it's like I just like to use named arguments. But for example here, when the variable is almost the same as the argument, I think I'll just not write that, but the refactoring will not catch that. So yeah, I think for the purpose of this project I will just write it everywhere, because I like it from the TypeScript when you're creating objects structures. It's very similar, but yeah, let's just keep writing like that. So we're finding a closest enemy. We have that one. We did the same stuff as before. All right. Let's just check if it's working again, whether we haven't broke anything. Some warnings, right? Oh, we have broke something. Okay, find closest enemy. What's wrong? Entities, maybe some. Oh no. Character team. character team, character AI, bridge. We're returning our transform. That's why it's always good to check after some refactor, just a small, after making a small step, because it's easier right now to find a bug, because you know the exact area of code you have changed. We're using the, what? Alright. I have not initialized any repository out here, so it's weird it's showing up, but okay. Alright, so we have a function for finding a closest enemy. So, what's next? And the AI is moving. Let's create an attack system. Yep. First of all, character statistics. We have damage. We will introduce attack range. And attack cooldown MS. So the milliseconds required to perform a next attack. Alright, let's create a component, character attack. And we'll store, as pointed out here, only attack start time, or maybe the next allowed attack, because if we change the cooldown, it would also change how fast we can perform the next attack. But we want to apply a cooldown that will last as it was set up before the attack. Character attack and attack start time. What? Next available time. I think it would be good. So this variable tells us when our next attack would be available. Alright. Let's just put a variable here, should perform attack. We are in the character attack, so we don't need to repeat ourselves by typing should perform attack, just should perform. That's good. And next available time. Alright. And for the purpose of attacking, let's create let's just attack the closest enemy. It's just some basic stuff, but we'll be extending it right now, just writing it to see how it's working. Okay, so perform character perform attack system.cs. Let's grab that one as a reference. Perform attack system. Okay. It would be very similar. So we are grabbing a transform, yes. Character, nope. Character attack. Character movement, nope, we don't need that, but we need team. Alright, closest enemy and character statistics, that's also important. Statistics. So, closest enemy transform. Find closest enemy. So, if there's no enemy, return it. Later on, we grab the distance to enemy vector 3 distance A vector transform B closest enemy transform positions. Right, and to perform attack, and if distance to the enemy is smaller or equal to the character statistics, attack range, then we perform an attack. So what do we do? First of all, let's apply the cooldown. Attack. Next about time will be time. What is an elapsed time? That's weird. Let's into ECS elapsed time. Let's see, I think elapsed time will be good. Here. Plus character statistics. What? Attack cooldown, milliseconds. I need to cast it to float. Alright. Maybe we'll do it like that. If distance to enemy is higher, then we return, otherwise we are doing something. And we need to apply a damage. So distance to enemy, and we need the character health. enemy health. Like transform, enemy transform. I just rename it to enemy transform. Enemy transform, get component. I don't have any other idea right now how to do it. Most probably we can do like get component, data from entity. Entities. No. And enemy health points minus character statistics, damage, attack damage. Yeah, let's keep the damage in the as the integer. Alright, so it should work right now, except that we need to do like if character attack next attack available. No, first of all should perform if we don't want to perform, or character attack next available attack time is more than currently elapsed time, and the return. No, let's put it in the separate line. I may not. Okay, we're performing an attack, we're subtracting a health, we're applying the cooldown. You just need to attack right now. You can do it manually, I think, in the ECS here. So let me stop moving and this is an enemy. Let's make his movement speed 0. But he's still moving, okay? So we're not using the movement speed at all. Character... Move character rigid body system. Normalize direction multiplied by character movement speed. But if we are, I mean, it should work if the direction is 0 in both axes. Let's see. Okay, he's not moving. We are only moving as a player. So, let's give us a 50 health. An enemy. Oh, will it work at all? It will, okay. Attack range as a 5. Attack damage as 1 and cooldown as 10. Oh, it moves so per second. Health points. Okay, is not attacking us. So range should be okay, the damage should be okay. No, the attack, character attack should perform. It's not working. Let's see why. Perform attack system. So we take transform, it's present, okay, character, statistics, and team. So if it should be performed or next available time is more than time elapsed time, then return, then find closest enemy. We should get that one. Distance to the enemy is more than attack range. Should pass that. I know. Character team, next available time is working at all in this system. Character perform attack. Matching results. Character AI. Character attack. It's okay. Character statistics is also here. Character team. Yep. Not run. That's weird. What if I disable? Oh. Okay, now it's working, but that's weird. So it means that we would need to re-register our game object in the entity world as soon as we add a component. But maybe I'm doing it wrong. I mean, we should add the component through some ECS functions. Is it losing our health? Okay, health points. Oh, it is a seconds instead of milliseconds. So let's do it like that, and it should apply damage 1 per second. And it's working. So we created a damage system, and if we move away from the attack range, it keeps hitting, but yeah, it stops hitting as soon as we move out of the attack range. So it's kind of working. Alright, we're not using any collision system out here to detect the attack, just some basic stuff. Alright. Alright, so we have some basic attacking system, basic health. I think the next thing we should work on is making it more look better. So some assets, adding some assets, some animations. Making an AI for attacking, so the character stops and attacks, and maybe block the movement if the attack is performing, and maybe not. I don't know, we'll see. Yeah, first of all, the importing some assets and making it look better. So I think it's all for now. I'm going to take a break. I know if it's a break taking 1 day long or break taking 1 hour. I'm going to eat something, and if I feel that I'm ready to stream more, I'll get back. Otherwise, the next stream will be in a day or two. And as I've mentioned, on next stream we'll be adding some visuals, some animations, and hopefully it will look much better. And we'll start adding some more cool gameplay. Because right now it's just bad, not good. I'd say. I mean, it's not that bad. It's just not that good. Yeah. So thank you for watching, and see you next stream.